So, I think it's time to start this session D315 on virtual and augmented and mixed reality. So, we have 5 papers here. I'm not sure if the presenter of the second paper is here, but let's hope he will arrive. And our first paper comes from Germany, some University of Duisburg, and presented by Steffen Kunnen. And like in these sessions, we will first see the videos, and I would like to put them almost shortly together. I might just shortly present the author, and I hope that the audience will type the questions on the this discussion chat on right, and then the authors can also prepare to answer and discuss on the questions later on. So we can go to first video now.
Hello and welcome to my presentation. My name is Steffen Kunnen and I'm a research associate at the University of Duisburg-Essen in Germany. I would like to present a system-based approach to identify components during the maintenance of an industrial plant in mixed reality. Let's start with a small outlook on the agenda. I would like to start with the problem statement and the research activities, followed by results and discussion, and finish my presentation with a small conclusion and outlook on future activities. The maintenance process of an industrial plant is usually performed manually and documented on a sheet of paper. This type of documentation leads to a couple of problems, since the gathered results need complex ways before they can be made available for further activities. Important information can be lost, so the question arises of how the collected data can be passed through without loss and preferably without delay from the place of inspection to the company's management system. The research activities focus on the development of an IT solution that supports maintenance personnel through a system-based component identification in mixed reality. So let's have a look at the developed approach. The concept for component recognition consists of 3 essential system elements: the system structure, a PDM system, and the HoloLens application. Within the system structure, 2 model types are created, the system model and the maintenance model. The system model describes the classical structure of the industrial plant with the respective assemblies and objects. In the maintenance model, the objects are assigned to corresponding zones or areas within the plant. The interface, number 3, to the PDM system then enables the automatic building of the product and maintenance structure in the PDM system. The most important characteristics of these objects, such as dimensions, coordinates for localization, and the specifications are also transferred to the PDM system. To carry out the maintenance, the information of the maintenance structure is then transferred to a HoloLens application. In the HoloLens application, the user has 2 possibilities to identify a component. On the one hand, he can select a point of interest after initialization of the zone. The coordinate is determined so that this point of interest can also be located automatically. The other possibility is an identification via bounding boxes, which are projected as 3D models over the respective components. These boxes can then be selected and corresponding maintenance results can be collected. The bidirectional interface between PDM and the application allows the transfer of the results to the affected elements in the product structure after successful maintenance in real time. The manual post-processing is no longer required and all results and data are immediately available for further activities. In order to be able to carry out the acquisition procedure with the bounding boxes, the corresponding components must be declared accordingly in the system structure. The underlying logic is shown in the system area diagram on this slide. Each object in the system is declared as a base geo object. The base geo object includes an offset for the location of the object in a certain space and the dimensions of a bounding box. This object type can be differentiated between single and grid geo objects. Single geo objects are components that occur only in smaller numbers and are arranged without a specific pattern. Grid geo objects are components that occur in larger numbers and are arranged in fixed patterns, a so-called grid. In addition to the base geo objects, the grid geo object also contains a base grid which contains the dimensions of this pattern. The HoloLens application determines the coordinates as well as the marked bounding boxes during the maintenance activity and can compare these with the system structure that the collected results can be automatically assigned to a specific component in the product structure. To finish my presentation, I would like to give a small conclusion and an outlook on future activities. In this presentation, a system-based concept for the identification of components in industrial plant using mixed reality was briefly introduced. The backend contains a system structure with all the required information. The central point is a PDM system for the data provision and storage. A HoloLens application in the front end is used for control and information retrieval during the maintenance process. The theoretical approach has already been successfully tested as a prototype in the real environment. In the next steps, the consistency of the data is validated and the details are further elaborated. This brings me to the end of my presentation, and I thank everyone for your attention.
Okay, thank you. And I ask audience now write some questions on the discussion chat table on the right on this presentation. We will discuss this on later. But do we still have the presentation of the second paper yet here?
Do.
Okay, then this paper comes from Ghent University from Belgium, and it will present it by Joundi Jamil, I hope. Please.
My name is Jamil, and I'm a PhD student at the University of Ghent in Belgium. Today I will present to you an explorative study towards using VR sketching as a tool for ideation and prototyping in product design. So the main question we asked ourselves is, can VR be used as a tool for ideation? The computer software we used to test it with is Gravity Sketch. Here you can see a short movie about Gravity Sketch and what its main purpose is. It's a freehand drawing software where the user can design shapes in VR with free-form controllers. So the next question we wondered in our research is, how important is the use of context when you're designing something in VR? We based our analysis on Warrell's 4 steps for evaluation of form syntactics in the design process. The first step is a selection of design elements to be studied. The second step is a generation and implementation of syntactic variations of selected design elements. The third step is the assessment of visual effects achieved by each variation. The last step is the evaluation and conclusion regarding syntactic functionality. Here you can see some related work, but you can read more about it in our paper. For our VR sketching experiment, we had 2 HTC Vives set up with Gravity Sketch equipped. We had 27 participants, 17 of them were male and 10 were female. They were all first-time users and design students with the age between 21 and 25 years old. The design task they had to perform in VR was the design of a drone which was inspired by nature. Half of the group could do this without reference material and the other half of the group could do this with reference material. This meaning 3D models, images, sketches they could use as an inspiration or as a visual guide. On this slide, you can see how the students used VR as a design tool. On the top row, you can see the comparison between the VR sketches they made and the sketches they used as a guide. And on the bottom row, you can see the VR sketches they made compared to the digital renders they submitted at the end of the semester. We also performed a questionnaire to see how the students reacted to VR. Most of them were surprised by the state of VR, but It was difficult to get the exact shape right they had in their head, and the dizziness was also an issue for some students. Also, some features complementary and similar to CUT are not implemented in VR yet. To most students, the envisioned purpose was the visualization of 3D shapes. The use of context was most useful as a reference for determining the scale and the look of the final product. Apart from the questionnaire, 27 observations were made from the students designing in VR. These were divided in 4 categories, as you can see here. After performing our observations and questionnaires, we mapped the different tools on the 4 steps of Werrell's process. We saw that many students used VR sketching as a means for form implementation and form evaluation. In conclusion, the positive observations that can be made were that the students were able to go from a shape ID to a closed 3D shape. Sketching can be done in a limited time frame, for example, 30 minutes, and the students themselves, they saw a lot of potential in this technology. Some problems that were observed, however, were that VR is not really that easy to be used as a form-finding tool, because drawing in the first place is complex and there is quite a steep learning curve with the controls in the software. The second point is that it's easier to style a 3D model when there is reference material present. For example, the blocks that are inside the products, assembly-wise, or sketches that can be used as a reference.
Okay, thank you and welcome, Jamil. We will discuss later on this paper, and I asked the audience on the papers while the presentations are going on. So now the third paper comes from University of Zagreb, presented by Nikola. Horvat, please.
Good afternoon, everyone. I'm Nikola Horvat from University of Zagreb, and in this short video, I'll present our paper focusing on identification of the effect of expertise on design reviews conducted with virtual reality and desktop interface technology. This paper is part of our larger research focused on the use of VR in engineering design. First of all, let me start with design reviews. They usually consist of 3 broad cycles involving understanding of the design under review, evaluating that design, and resolving design issues. While visualization might be crucial for design reviews, previous studies usually resulted in inconsistent findings. We believe that this is because these studies mainly focused on design review outcomes, such as number of identified design errors. Therefore, in this paper, we decided to focus on design understanding part of design review and include expertise as one variable that might affect design understanding. Basically, we conducted experimental study on 40 students where we assessed expertise in terms of technology experience, design experience, contextual experience, and spatial ability. For the first 3 categories, we used questionnaire where we asked about their experience in these categories, while for the last category, we used mental rotations test. When we then gave them a review task in either desktop interface or VR environment. The design under review was a foldable electric scooter, and as you can see on the video, participants had CAD model of both scooter in driving mode and in folded mode. The task was to identify folding steps necessary to transform the scooter from the driving mode to the folded mode. We used two-way ANOVA to identify if any of the models with expertise and visualization was significant. Basically, all the ANOVA models showed significant effect of visualization, while the effect of expertise depended on the metric. The effect of visualization was in favor of desktop interface in all the models. For experiencing technology, the mean values increased for both groups, but the difference was not significant. In the second ANOVA model, the effect of mechanical engineering experience was significant. The effect of contextual experience was significant for one metric, but not for the other. And finally, the MRT was similar to the technology experience, as it increased the mean in both environments, but its effect was not significant. All the results showed that the desktop interface resulted in better understanding of design. It's not clear whether CAD features or higher experience in CAD versus VR affected this conclusion. Since mechanical engineering experience, technology experience, and spatial ability all positively affected means, and the sum of the variables were significant, we suggest that researchers control for these variables while assessing the effect of visualization on design reviews. However, future studies are necessary to support our conclusions and examine the effects more in depth. One approach could be to investigate further design understanding construct and to assess how it affects review performance. Another approach would be to incorporate other review cycles and assess the effect of technology. We actually conducted a study in this direction, where we asked a virtual team to review their design using a shared list of requirements and CAD model in Onshape. As you can see on this video, we'll present these results next year, but we welcome any suggestions to improve the quality of our research. Thank you for your attention, and thanks to Croatian Science Foundation for funding this project. If anyone is interested, here I suggest our recent publications related to this topic. Stay safe and healthy and enjoy the conference.
Thank you. Surely we will enjoy this conference. So our fourth paper comes from University of Bath by Lorenzo Guinta. So please.
Welcome to this presentation on investigating the impact of scale in design sessions supported by a spatial augmented reality tool. My name is Lorenzo Giunta. The two other authors contributing to this paper are James Gopsel and Elise de Koning. The experiment was run as follows. Two participants were informed that a fictional watch company had hired them to design a watch and that together they would have to create a number of concepts for this company to evaluate. To do so, they were provided with an SAR platform to visualize their designs, an inspiration board showing the watches the fictional company wished to compete with, and a set of digital graphics that could be mixed and matched to create new designs using the SAR platform. Two conditions were tested. One where the model used in the SAR platform was at a 1:1 scale, and one with a 2:1 scale model. The participants were told they could take as much time as needed and to ring the bell whenever they had generated a new concept. Only one participant had access to the interface to control the SAR system, but participants were made aware that the projected model would be used to evaluate their concepts, and thus they should rely on that for the visualization. On completing the design activity, the participants were asked to complete a survey, as well as comment on the concepts they had generated by stating whether they would take the concept forward to be seen by their fictional client. The inspiration board provided to participants is shown here. It consisted of 17 watch images, all of similar styling, and participants were informed that their concepts would be aimed at competing with these watches. Some of the digital graphics provided to the participants are shown here. In total, they were provided with 20 different graphics they could use at their pleasure. The background color of the watch and watch face could be changed manually and could be set to any color. Data collection focused on three main things: concept generation process, ease of designing, and design behavior. The concept generation process was measured by analyzing the total time taken to complete the exercise as well as the number of concepts generated. The ease of designing was evaluated through a creativity support index survey. The design behavior was analyzed by recording the percentage of assets used, the individual asset usage across conditions, the asset use, and the interaction across both scales. We will now look at some of the results from the experiments. This graph shows the time taken to complete the experiments across both conditions. As is clear from the graph, the participants using the 2-to-1 scale model took significantly less time to complete the task. Here we can see the amount of concepts generated. In contrast to the previous graph, we can see that the amount of concepts generated was higher with participants working with a 1-to-1 scale model. The results of a CSI survey, used to evaluate the participants' comfort with the SAR platform, provide no conclusive results regarding which scale model is most comfortable to the participants. The participants using the 1-to-1 scale model appear to have used a larger percentage of the available 20 assets when compared to the 2-to-1 condition. However, there is still some overlap between the two conditions, and it is currently impossible to draw a firm conclusion based on the limited data collected. This graph shows a percentage of sessions that used a specific asset across both the 1-to-1 and 2-to-1 scale conditions. As can be seen, participants in the 1-to-1 scale always used the week count, minute hand, and logo assets. Furthermore, they used 11 assets in more than 50% of the sessions. In contrast, the participants in the 2-to-1 condition were much less firm in the selection of assets. One interesting effect was noted during the processing of the data collected. It appears, as is shown in these graphs, that the participants hardly ever reworked an existing asset once it was placed. Rather, they would place an asset, work on it for a time, then move on to the next asset instance, following a waterfall pattern. The most interesting points highlighted by the experiment were these. Participants in the 2-to-1 condition always selected concepts to be taken forward. This, coupled with the time taken and the number of concepts generated, indicates that the participants in the 2-to-1 condition were more methodical in their approach. This is further substantiated when looking at the asset usage in the 1-to-1 condition, where a much wider number of assets was used, suggesting a more explorative approach. There did not seem to be any difference in the experience of the participants in either the 2-to-1 or 1-to-1 conditions based on the CSI survey. Analyzing the asset placement behavior revealed a waterfall effect. This was constant across both conditions. In conclusion, the results highlight two main learning points. Firstly, that the scale does not seem to impact the enjoyment of the designers when using the SAR platform. And secondly, that the scale plays a role in the number of concepts generated, the designer's satisfaction with these concepts, and the usage of the digital assets provided. Going forward, it should be a goal to increase the sample size and variation by using more scales, analyzing the impact of scaling down, and looking at participant satisfaction when designs are returned to a full scale. Thank you very much for your time and attention.
Okay, and our final last paper comes from Germany, from University of Applied Science in Australia, and presented by Hans-Patrick Balcerkiewicz, if I pronounce it rightly. Please.
Hello and welcome to my presentation as part of the Design Conference 2020. My name is Hans-Patrick Balcerkiewicz and my research topic is about the evolution of virtual reality during the usage in early design phases. I would like to start my presentation with some general aspects about VR and product development. VR can be defined as a computer-generated simulation of three-dimensional objects or environments with seemingly real, direct, or physical user interaction. VR technology allows the users to see future products and early concepts in a real-world environment without needing a physical product like prototypes or something like that. And currently, VR technology is mainly used in the later stages of product development, for example, in the context of design reviews. And this leads us to the question, why not using VR in the early stages of product development? Well, there are software solutions that could be used in the early stages of product development, like Google Blocks or Gravity Sketch. But these software solutions come with some problems like poor data security or that there are no multi-user systems. Especially in the early phases of product development, the product data need to be exchanged between different software systems. And therefore, the main problem of using VR in the early design phases is that the transmission of product data between VR and CHD is not possible currently. This is due to the fact that CHD systems work with solid models, while VR systems work with tessellated surface models like the sphere that you can see in the picture. The geometric informations of the surface model, like nodes and edges and the single surfaces, are stored in STL or OBJ files. And these informations are not enough to create a solid model in a CHD software. Due to this, we developed a system to enable the automatic transmission between VR and the CHD system CATIA. And I would like to explain our system with an example. On the left side, we have a brick that is a surface model, and in the first step, we analyze that brick and we divide that brick into simpler models like this block or the spheres. In the next step, based on the geometric informations, we calculate the model parameter like depth or width or the center point and radius. These parameters are fed into CATIA, and based on this, CATIA can create the solid models that are corresponding to the surface models before. In the last step, we use Boolean operations to intersect the created solid models, and finally, we have created our surface model brick into a solid model brick. Our system works very, very well, but in the next step, we want to increase the complexity and the stability of the transmission process. And after that, we want to raise the transfer speed and enable more CHD systems like Creo or NX or Autodesk. So that was my presentation. I thank you for the attention, and I'm looking forward to the discussion.
Okay, now we have seen the videos of all of our presentations, and it's really nice to see that there has been quite good discussion going on in the chat channel already. But I didn't find, did we have any questions for from the first paper by Steffen Kunnen?
I think there was one question.
Okay, I think I would still like to have this real physical discussion. So you can explain more on that.
Okay, then I can start. It was a question from Mr. Škec, I hope I told it right, about the perception of AR, VR, MR devices for the company or the maintenance personnel. I tried to answer it like a little bit in the discussion, but we can do it in the chat now. At the first start or the first discussion we had regarding our project, so to improve the maintenance process, the maintenance personnel didn't really know what AR is. So they just had heard or saw something about virtual realities. Everything they started to discuss or wanted to improve was the visualization of the results. But with further progressing of our project, the benefits of AR, so connecting virtual with a real environment, became clear. And now the benefit is really visible because we can connect the virtual and the real world. So we can use, for example, we call it notations. We can make pictures and, for example, text or voice recordings and connect them to virtual objects. So we have the connection between digital and real world. And that is one of our biggest improvements. So the data continuity, so the data transfer from, for example, start, so the preparation to the virtual devices, back to the PDM system, so the data collection system, it works pretty well. And our first prototype was developed, I think it was finished like 2 months ago, and we did a test in the cell cooling tower. And yeah, after that, everyone was very, very happy because it worked very good. So that's my impression. They all started with VR or they just saw the VR benefits, but now we're slowly going to the benefits of AR as well. I hope that answers the question.
I think so. One of the things that I was wondering if you are introducing this, how heavy the information system will be in the product data system if you, let's say, include the complete factory this way?
It's pretty tough question, because our first product we tried to validate was a cell cooling tower, and the cell cooling tower is pretty easy because it has like a small product structure, and in our system model, so the system model, we create the whole system. So we describe the whole system architecture. And this whole architecture is then transferred automatically to a PDM system. So the main work is to create the system architecture. And the larger, I hear myself again. And the largest work we have to do is to create this system architecture, which contains the whole information about, for example, a power plant. I think it's pretty necessary to reduce the volume of this system architecture, because not every component can be maintained with AR. It's really beneficial, for example, for specific zones. And if these zones are then displayed in the system model and then automatically transferred to the PDM system, I think that's what would bring out the biggest benefit. So focus on these zones or these objects which are really good or which have the biggest potential to use for AR maintenance.
Okay, thank you. So I noticed that there was several questions for the second paper by Jamil Joundi. So maybe you would like to discuss about those.
Is it okay if I just pick out the questions from the chat again and try to answer my own words?
Yes. Yeah, because problem is that these answers are typically so short and questions, so that I think you might give more explanations.
Okay, I'll try to do so. I'll start with the one from Nikola. So the first one, have you considered having two objects, one on one scale and other in a large scale, and analyzing the dynamics? Oh, am I looking at, no, I'm looking at the wrong question. Excuse me. I have to scroll back. Okay, yes.
Yeah, okay, you go.
Sorry, Nikola, I found it again. So you said, I think that you raised important points related to lack of intuition for sketching in 3D space. I was wondering whether you have some idea about the training for immersive sketching. For example, there are already existing learning methodologies for VR sketching, or do you have an initial idea how it should look like? Yeah, that's true. In our paper, we did a very early training with the students. So they never touched VR before. They were first-time users. But that's what I personally think makes it interesting, because any good design system should be accessible for people that don't have experience or a lot of experience in it. However, it is useful to note here that they were able to make models in the 30-minute time frame. So this already gives an indication of how easy it can be compared with CAD modeling tools. So this is kind of an interesting question from you. I'm not sure whether it's a good idea to give training sessions for immersive sketching. I think it should be actually the other way around, that there is still a long way to go to make it as accessible as possible, the tool to use, and that people train themselves actually, as to say it, so that they learn how to use it and become an expert. Some people are very advanced in this already. They can make really nice VR sketches. I've seen those, but there are not that many. So I think there's still some work to do on the software, more than there should be like training sessions especially designed for it.
Yeah, but maybe just to introduce that some kind of exercises in design curriculum or something. Maybe that could be like, maybe it will really help the students to cope with new technologies, so that once when they when we use them, for example, for our experiments, so that they already have some idea. You said in chat, you wrote that you are already quite good, but so maybe have you thought about some kind of methodology you just learned by heart, just a deliberate practice, you were just practicing, or you had some sort of methodology? You know how students use CAD. Firstly, they learn how to sketch in 2D, how the sketch behaves in computer-aided design software, and then they learn how to extrude, revolve, etc., and then they go on surfaces, etc. So do you maybe have some idea on how that might be implemented in a design curriculum?
Yeah, there are some tricks you can do. For example, you start, for example, with the mirroring plane instead of starting in the random space, because there is no reference there, so it becomes very difficult. Some other tips are starting on the 100% scale, so you don't have to resize it at the end. And then you can scale it up in the software. So this is what I meant with the software is still changing, and it's still very early to give hard guidelines, but you are right in the fact that maybe for translation, it's better to translate according to the X, Y, or Z axis, instead of just picking something up and placing it somewhere, because afterwards it becomes very difficult to get it back in the exact same position. So there are some tricks there. Also using nodes for everything instead of just drawing with a free hand. Afterwards, you simplify your curve to have as little nodes as you need. It's a bit similar to NURBS modeling. And then it becomes easier to get this really sharp looking tight curves. So there are things to do there, but yeah, maybe it's useful to make a manual or something. So you address the basics that you need to know, and that's something that could be very useful.
And just as a rough estimation, how much time it took you to that you became familiar with Gravity Sketch, if I'm right, that you use that software?
Yeah, I use Gravity Sketch indeed. That's a difficult one to answer because I don't really focus on using it every day. So it's been spread out over a longer period of time. But I think in a couple of weeks, you could be very profound in using this software. So it depends on your efforts towards it. So how many times you will use it and if you really want to use it. And otherwise on learning the right tricks, as I mentioned a bit. So you don't start always without knowing what you want to do. With a clear plan, you get indeed a lot further. And also I want to mention here that it's also useful to use prefabs or models that you already made into the sketching scene, so you have a reference. For example, if you want to make a new mixer, you can import all the assembly components that are inside the mixer, so you can draw around it. So this is also something that's also useful for CAD, for example. You import the components and then you can make your casing around it. So those are things that you also learn by learning about design more. It's not only specific to Gravity Sketch itself, but I hope this was a clear answer to your question.
Yeah, really clear. I would like really to discuss that more with you, so we can maybe catch up in Gather Town later on. So that we can have time of this discussion. Perfect. Thanks.
Yeah, okay. Send me a personal message and I'll come back to it.
Thanks.
Okay, do I have to discuss the other questions as well? I don't know for the timing if it's possible to do it, but
we have some time left, yeah. And also it's a very good idea while we have this nice virtual social event when you know each other's now a bit to discuss also later at afternoon.
Yeah.
So one of the things with VR is always confusing me because understanding the dimensions are typically difficult. So if you make sketches and if you would need to put them on certain dimensions, would there any let's say easy way to do that?
Yeah, so there are two things you can do there, right? You can import a model that you know the dimensions of really well and then work around it so you have a feeling to it, but that's not very precise. And then another tool that Gravity Sketch introduced is like a ruler. So you have a ruler on your to say, and you can open it and you can check dimensions that way. But that's what I meant with this is like a very early implementation of how you would want it to be, because I can imagine in a better scenario is that you just select 2 points and you can see the distance between it. So you don't have really to take out a ruler, but you just go into measuring mode and you're able to measure all different kinds of detailistic things you want to know. But there are other softwares that allow this better. You have, for example, a tool for SketchUp in VR that I noticed passing by a couple of weeks ago, and there you already have the ruler when you're drawing. So it becomes more intuitive then, I guess, than just drawing it first and then afterwards measuring everything up. So this is what I meant with, I think personally it's still a bit in development, and yeah, it's just a matter of making a good application for it or making a useful tool inside the software to do it. Yeah, this is my opinion.
Yeah, I think this virtual reality is really phase of maturity and in the development, so that there are a lot of different kind of products that are coming quite frequently. And I think one of the issues is to understand what the tool to use and what the advances are.
Yeah,
okay,
exactly.
But yeah, now we can go to the third paper by Nikola. There was many questions I noticed.
Thanks. Yeah, let me just go. I think first question was from Professor Gopsil, Dr. Gopsil. So he's basically saying that CAD experience is relatively low, was 0.5 years. So do I feel that more than 5 years of experience would have greater effect? Yeah. The thing is, what we wanted to do here is just to see whether experience would affect understanding, like part of contextual understanding, not just estimation of dimensions, but also like contextual part of understanding. Do they know how this work, how this mechanism work? So more related to design. And for that, I think that there are like a lot of theories that suggest that experience is like really important for this kind of understanding. So although we did not test that in our research, I think that it would have greater effect.
Yeah, it's fantastic. Thank you, Nikola, for responding to my question. Well, I think that's the interesting result, is that, you know, even with only half a year of experience, that you get such a step change in capability and the results and the change. And in this kind of era of moving to more multi, even transdisciplinary working, where we're trying to bring multiple disciplines together to solve our societal challenges, it may be a case that you can try and identify, well, you know, if I'm outside of the engineering discipline, as long as I do maybe a 2-month course on it or a 6-month course, it will give me enough skills to be able to partake in these activities and provide some beneficial input into those design challenges, but from a different stakeholder perspective. So yeah, really interesting findings, and I'd like to see where it goes. Maybe even, you know, cutting it even shorter and say actually give someone a month's training program, see what the step change is and stuff like that. It might be a really insightful experiment to continue with.
Yeah, thank you. Yeah, that's really nice comment. We actually plan to do something in that direction. So yeah, I think that it's really interesting, and this is why I asked Jamil to discuss on how much time it will take to learn virtual reality sketching, because it's what we think that it might take less time to become familiar in virtual reality as well, and that this short-term course might really help them in in their results. Thanks.
No, thank you.
So I believe that there was, if there is time, there was one more question for me.
Yeah, please, we have time.
So just hold on. I think that there was something about obstacles in design reviews. You really filled in this chat, so I cannot really find it. Anyway, yeah, because the question was something about what are the main obstacles of using VR in design reviews, was something about that. So basically what we think that there is, first of all, of course, as Jamil already said, it's technology which is not great at the moment, and there is still like some people experience lagging, some devices which are accessible to most people don't have a high resolution. Software is not really appropriate. For example, for mechanical engineering, very few tools have a section which does not show you whole of designs, that so that they can show solid models when you do section view in VR. So technology is for sure one obstacle. Another, I think it's a lack of understanding how 3D models are used during design reviews, because when you have design review, I mean, CAD model cannot help you for everything. So it's not really just replacing the whole design review with virtual reality, but it's some kind of augmenting design review with virtual reality, so that for those requirements where virtual reality can help you, so that for those, we think that it's most for that first part of design review where it's understanding of the design. So I'm not sure whether you remember my 3 cycles: understanding, not mine, from the literature, understanding, evaluating, and resolving. So basically, we believe we think that it will help most in that understanding part of design reviews. And yeah, it's just to understand more for what kind of products and for what kind of, for example, requirements VR can help more, that then the industry will start implementing. I hope that answers the question. I'm not sure whether I was clear enough.
Yeah, it answered the question. It was more like a general question, because as you said, more is required than just the 3D model to make a successful design review. We need requirements, we need all the data we can collect from maybe simulations. And my field of research is actually how can we get all the information in a VR setting and use them for execution of a design review. So your focus was more on the experience within the execution. So how can we use 3D models, for example, and use the beneficials of VR compared to desktop interfaces, and not how can we use, for example, VR as a tool for documentation of research, of results from design reviews, for example. Okay.
That's really interesting.
Okay.
Steffen, do you mind sending me some papers related to your work so I can take a look into that?
Yeah, we can make a small session maybe later on, if you want.
Yeah.
Maybe next day. I'll send you a direct message.
Yeah. Okay, thank you. My impression is that at least in my country, in Finland, the industry has quite well adopted virtual reality in, let's say, product review, especially in the cases where the visibility is important. I think this is one of the main advantages of that technology. Okay, then we go to the 4th paper by Lorenzo. Please.
Yeah, I believe there was only one question from Nikola, or actually 2 questions. So the first one was about having 2 objects, one in 1-to-1 scale and the other one at a larger scale, and analyzing the dynamics used. So actually, I replied to that in the chat because I wasn't entirely sure what you meant by dynamics, because
yeah, I've heard on that. Yeah, it's basically if during during review session they would have two prototypes, one with 1-on-1 scale and the other one which is enlarged. Basically by dynamics, how much they used 1-on-1 scale, how much they used enlarged scale, and for what purpose they used each model, so that you have simultaneous scale. This is, maybe it can give you some interesting results, maybe more insights about how you should develop your tool further or something, just as an.
Okay, now I understand what you mean. So our experiment was specifically aimed at trying to understand the not whether or not people were not really specifically whether or not scale had an impact, because we do know scale does have an impact, but trying to understand where this impact lies most specifically. Unfortunately, in spatial augmented reality, you must have a prototype onto which to project, and the production of these prototypes is time consuming and inefficient, because you often need to 3D print them. Some of these models can be very complex. It can take upwards of 24 hours to produce. So this was more to kind of understand as a guideline which, so if you were to start a design review session, which kind of model would you need for a specific stage of that design review session? And I agree it could be interesting to use maybe some gaze analysis to try to see what if we had multiple models available, to try to see where people are looking at for which task. But we conducted some post-session interviews as well, and it seemed that people are always turned to favor larger scales immediately, because it's just easier to see what's going on. The resolution tends to be higher. But the issue we haven't investigated yet, but we think is going to be a major problem, is when you return the object to its actual scale. So it might be that it's easier to work on a 5:1 scale for the watch because it's nice and big, but it can lead to making design decisions that make no sense when you scale it down, because all of a sudden all the numbers are really, really tiny. So that is actually something we mentioned as future work we should be looking into. But yeah, it would still be interesting to kind of see how which kind of models would be favored if there were multiple models available. And as far as
I totally agree with you, and basically I'm looking forward to your future work, just to see how it ends up with all that. Yeah. So yeah, I really agree with you that you got some interesting findings, and but I think that when you return back to 1:1 scale. So what was my hypothesis when I was reading your paper, that maybe so for generating alternative scales, bigger scale would be better, and then quickly evaluating on a 1:1 scale just to see how it looks like. Just my idea why I mentioned to have both models over there. Yeah. Thanks.
Okay. Maybe I have a more general question about this spatial augmented reality system. So what kind of limitations you would see when using that?
Well, the major limitations of the SAR are usually the projection envelope. So whenever we project onto something, there's a maximum reach the projector has, and depending on the type of projector we've chosen for that particular model, for that particular setup, you're limited in how large a prototype you can work on. This also, and the resolution of a projector impacts how small a model you can project on. So those tend to be the two limitations that really work as far as scale goes. We've also had issues with color resolution. Unfortunately, projecting colors is quite complicated. In particular, as a matter of fact, projecting black, because it's just not possible. So making sure that the entire room has a correct lighting that doesn't impact how the participants view the model plays a major role. It's why we focused more on looking at the assets they selected rather than the colors they used, because those tend to change even just by the time of day, depending on the amount of light that enters the room.
Okay. Thank you. So I think time goes, so we need to go to the final paper.
Yes, thank you.
By Hans
I hope you
Patrick.
can hear me.
Yes.
I think there are just two questions from Daria Vla and João Pereira, and I would answer them together. The question is about the main challenges and curved or freeform surfaces to transform them from VR into CHD. And I think that is the main challenge, to convert more complex models from VR into CHD, because Actually, we use geometric primitive models, and we have clear parameters like radius or height. And if we use freeform objects, we don't have any of these parameters to convert the VR model into a solid model. And yes, I think it would be very difficult to solve this. And I think it is necessary to limit the complexity of these freeform objects. Yeah, and I hope this answers the two questions.
Yes, surely. The problem with complexity is quite obvious when you start to visualize something very complex, that you quite easily notice that your latency is getting to be quite high if the model is too complex with modern computers.
Yes, and it's not easy to describe these freeform models in a mathematical way because they are just like splines, and a spline can be infinite, and to describe something infinite in a mathematical way is very complicated.
Yeah, true. So, is there any other questions for Hans?
Actually, yes, just a quick one. So, I don't know how relevant this might be, but as part of my work, I've had to turn STLs into solids, and I found that there is already some commercial solutions for that. I don't know how applicable this is for your work, or how this connects to the work you've presented here.
Yes, there are some commercial versions to transform STLs into a solid model, but you need a high degree of manual work, so it's not fully automatical. And our approach is to use a fully automatical system to convert the objects. You're welcome.
Okay, I think we have mostly used our time quite nicely. I think this seems to be quite a successful way of having conference. Especially, I enjoy this possibility to have a chat. But of course, I miss the live event with full discussion. But I think the audience and authors has really managed well here, and I want to thank you for, let's say, making this session possible and publishing your nice work here in this conference. So, within this word, I will close this session, and I hope a nice conference for you. And keep in mind this social event later on at afternoon. So,
thank you.
Bye.
Thank you.
Bye.
Bye.